For question number 4, we are asked to find the matrix, the inverse of the matrix 3, 4, 5, 2. And we use the solution to solve these two equations simultaneously. Now, to solve the inverse of a matrix A, that is A inverse, we find the adjoint of A over the modulus of A. Now, to solve the determinant, that is the modulus, determinant of A first, 3, 4, 5, and 2. Then multiply 2 and 3. 3 times 2 will give me 6. Multiply 5 and 4 minus, this is 20. 6 minus 20 will give me minus 14. So my determinant is minus 14. Keep it. Let's solve the adjoint of A. To solve the adjoint of A, we rearrange the elements of the matrix 3 and 2 with interchange. Then take the additive inverse of 5 and 4. To do this, I'll have 2 and 3. 2 and 3 have interchanged. Then the additive inverse of 4 is minus 4, minus 5. This is adjoint. So put this as a fraction of 14. I will have my A inverse to be equal to 2 minus 4 minus 5 and 3 over negative 14. Use negative 14 to divide all two. I will have my A inverse to be equal to minus 2 over 14, minus 4 over minus 14, minus 5 over minus 14, then 3 over minus 14. Let's break it down. My A inverse will become 2 divide itself 1, divide 14, 7. So I'll have minus 1 over 7. Then here, 2 can divide 2, 2 can divide 7. But minus and minus will cancel. So I'll have 2 over 7. Then this, nothing can divide, but minus and minus can cancel. I'll have 5 over 14. Here, nothing can divide. So I'll have minus 3 over 14. So this is my A inverse. So let's use it and solve the simultaneous equation. So I have 3x plus 4y to be equal to 1. And then 5x plus 2y to be equal to 3. Arrange the coefficients of the variables in a matrix equated to this also. I'll have 3 and 5, 4 and 2. Then multiply it against the variable x and y equal to this. This is a column matrix. Now to solve for x and y, let's call this A, B, and C. To solve for B, this guy will have to move over this side. Then you have to come over this side. So we divide both sides by A. I'll have my B to be equal to C over A. So this is something as B equal to C times 1 over A. And 1 over A is something as A inverse. So to get my B, which is these variables x and y, I'll use C and multiply A inverse. But remember that we have gotten A inverse as this guy, and our C is this one, okay? So multiply this and this. Solving for B, my C is 1 over 1 and 3, 1 and 3. And then my A inverse is this guy. So I'll bring it here. Minus 1 over 7, 5 over 14. I have 2 over 7 minus 3 over 14. This is it. So to multiply, we multiply column against row. So 1 we multiply here plus 3 we multiply here. We come over here also. 1 will multiply here plus 3 will multiply here. So let's go. So 1 times here, this is 1 times minus 1 over 7. Then 3 times here, 3 times 2 over 7. Then the same thing will happen here. Remember, we are adding. 1 times here, 1 times 5 over 14 plus 3 will multiply this. 3 times minus 3 over 14. 1 times minus 1, this will give me minus 1 over 7 plus 3 times 2 will give me 6 over 7. 1 times 5, I'll have 5 over 14 plus 3 times minus 3 is minus 9 over 14. Then let's add. 7 is common denominator, so I will take 1. Minus 1 plus 6 will give me 5. 14 is common denominator, 14. 5 minus 9 is minus 4. Can it break down? 2 can divide here and divide here. This is 2 and 7. So my final answer, B, which is equal to x and y, is 5 over 7 and 2 minus 2 over 7. This becomes the solution of this simultaneous equation. You can solve it normal using elimination or substitution method and see if you will arrive at this solution.